Welcome to another very important and the basic class of chemistry. And this is the third class of chapter chemical bond, and you know that I have already uploaded two classes on valence electrons and valencies and then about radicals. I tried to write some sort of elements in front of you so that you can understand that this class is the foundation of your chemistry knowledge, and you should not skip any concept or anything from this class actually, because you know that you have to study a lot then after about the chemical formula, moles, and then chemical reactions, and then a lot of things is coming. So if you understand this concept well, then it would be more easier for you to understand the next topics. So this is about the chemical formula, and you must know, before going to explaining these things, I need to say one thing, that you must know about the elements valency and of course the radicals valency. That is why I uploaded two classes previously. About radicals was the second class, and the valence electrons and valency was the first class. So now if you see that, do you understand and do you remember the valencies of different elements? And of course I know that if you want to know about chemical compounds and the formula, you must remember the valencies of elements. And you know that how many types of valencies are there? So maximum valency, latent valency, active valency, and variable valency. And you know that there are some elements those have more than one valency, and these are called the variable valency, like nitrogen, like sulfur and lead, even iron. So some of you may have a questions why this variable valence will happen. So I said that I'll definitely upload another video why there are some different valencies, like what is the reason behind the variable valency. Now you see, I definitely wish that you know all the name of these elements, because I took it from your books, especially SSC level physics, chemistry, and English versions. So these are very commonly used elements in chemistry, but you can go through your periodic table till 50 elements, and you must remember the valencies of these elements. Now you see, they are written like ammonium, phosphonium, nitrate, nitrite, hydroxide or hydroxyl, bicarbonate, bisulfate, sulfate, carbonate, and phosphate. And you see there are hydrogen, lithium, sodium, potassium, magnesium, calcium, aluminium, iron, zinc, lead, nitrogen, silver, fluorine, chlorine, bromine, iodine, which are actually group number 17 elements, and these are the halogens. And boron, phosphorus, copper, oxygen, carbon, and sulfur. These are very commonly used elements in your chemistry book, and there are a lot of others actually. So now, as we are focusing on chemical formula and the compounds, we need to know one basic. The basic is, very commonly used compounds is water. So you know that water is formed by hydrogen and oxygen. And what we do actually, we do that the valency of hydrogen is 1 and the valency of oxygen is 2. Now we need to exchange the valencies in between these elements to write down the chemical formula of these elements. So if you change this one from here and this one from here, it would be like what? It would be like H. So this would be written as the subscript, under the symbol of the element in a smaller way, and then this is O. We should not write this is as like that, no. So it should be written like this. So the number of the elements, I mean the valencies, as the number of atom should be written as the subscript after the symbol of elements, and this is called water. We know it well like this. If we say about carbon and hydrogen, you know what is the elements will be formed, or what is the compounds will be formed grouping like this, carbon and hydrogen. We know that the formula, the valencies of carbon is 2 and 4. Right now, if 4 is used and then hydrogen is 1, is always 1. So now we can say that if we exchange, then it would be CH4, which is the chemical formula of methane. So methane is a chemical compound, and CH4 is the chemical formula of methane. So writing down the chemical formula, what we need to know, that methane is the compounds formed by carbon and hydrogen, and we just we just exchanged the valencies of these elements. Like if we say that nitrogen and hydrogen, this is very common, that is why I am starting from the common example, then I will go further. See nitrogen, the valencies of nitrogen is 3, where the valencies of nitrogen is 3, you see it, 3 and 5. So now if you see, like N3 and hydrogen is always 1. I'm giving example based on hydrogen because the valency of hydrogen is 1. So as you know that the capacity of making a bond with another atom is the valency of the element. So as oxygen is taking 2 hydrogen, so the valency of oxygen is 2, the valency of carbon is 4, the valency of nitrogen is 3. Now you see that if we exchange, it would be like N1, so we would not write 1 as because it has no change, it would be NH3. This is the chemical formula of ammonia. So you know that the compound's name is ammonia, but the chemical formula is NH3. So you know it well, the chemical formula of water is H2O, methane and ammonia. These are very common. Right now, if you see that phosphorus and chlorine, so the valency of phosphorus is 3 usually, and chlorine is 1. We know that chlorine is 1 and phosphorus is 3 and 5. But if we use 3 here, so it will change their positions and then it will be like PCl3. Or if we use 5 instead of 3, then it will be like PCl5. So we have 2 compounds based on the different valencies of phosphorus. Now we can say this is the name of phosphorus trichloride. So we say that PCl3 is the name of phosphorus trichloride and PCl5 is name of phosphorus pentachloride. You know that the word tri means 3. So it has 3 chlorine together, it has 5 chlorine together. So it would be pentachloride. So I hope you understand what is tri and penta, the difference between tri and penta. So we can say these things again, one thing, like if you say that sulfur and oxygen, okay, and again sulfur and oxygen. I'm coming with the radicals later on. Now you see that sulfur, the valency of sulfur is 4 and oxygen is 2. What will be the compounds, the chemical formula is this? Because there is an, we make it simpler. So if we say that this should be 2 and 1, then it will come here and 2 should come there. So it will be like SO2. Or even if you see that sulfur is here 6 and oxygen is 2, then you can change it as 3 and 1, so it will be like SO3. So now we can say that this SO2 is the chemical formula of sulfur dioxide, as because it has 2 oxygen, and here we can say this is the chemical formula of sulfur trioxide, as because it has 3 oxygen. So you see that sulfur dioxide and sulfur trioxide, based on what? Based on the variable valency. So we have this variable valency, and based on we can have lots of compounds. Like this class may be like 1 hour long if I want to give you the at least 200 chemical formula or the 200 compounds name. So I'm just removing it to give you some another example. Like what else? Like you see that here is lithium, okay, and suppose there is fluorine. So if you see that lithium and fluorine together, you know that both elements will have one valency, so it will be same. So it would be like lithium fluoride. So we will say lithium fluoride. And you see that if like magnesium, if magnesium was added with chlorine, then magnesium and chlorine, you say that the valency of magnesium is 2. So now if I say 2 and chlorine is 1, then we exchange, then this 2 should come here and this 1 is here, then it would be MgCl subscript 2. And this is the chemical formula of magnesium chloride. Or even if you say that this is silver and this is bromine, then you think the silver is 1. What is silver? Yeah, silver is 1. Then we can say this is 1 and bromine 1. So the chemical formula would be the silver bromide. So it will be here silver bromide, and you must know the writing style of these compounds. We should not say like, we should not do like this MgCl2. No, not this way. It should be MgCl2 as a subscript. So the number of atom of an element should be written as a subscript after the symbol of the element. This is very important. Now you see, this is the easier examples. So you can pick anything from this, and you must know the positive part. The positive part should be in the left side of the compounds, and the negative one should be the right side of the compounds. Like if I say that aluminium and oxygen. So think about aluminium. The aluminium, the valency is 3 and oxygen is 2. Now you say, what should be the formula of aluminium oxide? So 2 comes here and 3 comes there. So it will be like Al2O3. And this is the formula of aluminium oxide, and you should not forget it ever. And like this. Now I have to give you some good thing about the name or pronunciation of some name when the variable valency will use. Suppose iron is added with chlorine, and you know that iron has two valencies, like 2 and 3, as it has a variable valency, and fluorine is always same. So now if you see, you can use both in this case. So if you use 2, then the formula would be like this, FeCl2. Or if you use 3, then the formula would be FeCl3. Now you say, what should be the name of compounds, these compounds? As we know that if there are more than one valencies of any elements, then if the lowest valency has used, then the name should be as. And if the maximum valency used, then we can say this is ik. So now the name of these compounds should be ferrous chloride, and the name of this should be the ferric chloride. So whenever you say, I'm having a very primary level discussions, students of English versions, students who are like standard 9 or very first level, you are watching this video, I must request you to not skip anything regarding these chemical compounds and the structural formula. So if you understand these things well, the next level chemistry would be easier for you and should be very interesting also. So now if you think about it, that in case of copper, Like in case of lead, you know that lead has two valences. Like what is lead? 2 and 4. You know that this is a Greek name, Latin name. This is plumbum. The element's name, the symbol of lead is Pb for plumbum. So it has two valences, 2 and 4. But if we use with lead chloride, then it would be like, firstly it can be PbCl2, and then it could be like PbCl4. Now you say what we can say on this, the naming of compounds, like this would be the plumbous chloride, or it can be, or it is actually the plumbic chloride. So now you understand that when we'll use the minimum valencies among these variable valencies, we should say as after the name of the element. So it should be plumbous chloride, and this should be the plumbic chloride. I hope you understand. And in this case again, even wherever you can go, like it should be like sodium fluoride. And if you want to mix up that sodium and silver, it should not be, as because these both elements are metal. They won't make any sort of compounds together. So why? Because this is positive and this is positive. So metal and metal do not form any compounds. Some differences are there, like sodium mercury, that is amalgam, that will be discussed later. But you see, so if you use it, nitrogen, with anything, like if you say like magnesium fluoride, magnesium chloride, magnesium bromide, magnesium iodide. But even if you see, there is another thing is boron. So we can say this is boron and chlorine, suppose, or boron and fluorine. So if you see that the valencies of boron is 3 in each cases, and also is 1 in each cases. Now the compound should be like BCl3, which is boron trichloride, and here it would be boron trifluoride. The chemical formula of BF3, that is boron trifluoride or boron trichloride. So we can say this because following the very simple rules we are forming the compounds. Like whatever. Now we think something special about the radicals. So now I'm removing it, and you must know that these are the radicals. And you know the definition of radicals? The definition of radical is the bundle of atoms from one or more than one elements formed together or combined together and possesses a charge like positive or negative, and they act like as ions. These are called the radicals. And I uploaded the previous videos where I explained about the radicals, and I said the same thing here, that this is the valence is 1, this is 2, and this is 3. So if you see the valency 1, these two are positive. So if you see the videos, I said that the valencies, the radicals can be two types, positive and negative. So in case of positive, this is ammonium and this is phosphonium. And whenever we write any name of compounds with these, the ammonium and phosphonium should be in the left side. Like what? But ammonium, if ammonium mixed with chlorine, then what will be? Like this is ammonium and this is chlorine. And we know that both elements, this radical's charge is 1 and chlorine is also 1. So the chemical formula of ammonium chloride would be NH4Cl, and this is ammonium chloride. And even if I say that this ammonium is working or adding with sulfate, two radicals can be added together. So if ammonium and sulfate, then you see that the valency of ammonium is 1 and the valency of sulfate is 2. Now what will happen? Like this 2 and 1 will change their space, and then the formula should be NH4 2SO4, and that is called the ammonium sulfate. ammonium sulfate. Or even if you see that ammonium is adding with phosphate, now you see that the valence of ammonium is 1 and phosphate is 3. So now what will happen? So it will happen like NH4 whole 3 PO4, and the name is ammonium phosphate. Now very interestingly, if the question is asked that how many atoms are there in these compounds, if the question is finding the atoms number from these compounds, then we need to calculate something. What are these? Now you see in these compounds how many nitrogen and hydrogen inside. If the question is finding the atoms number, then we see this is nitrogen 1 and hydrogen 4. So together it has 5 atoms inside and outside is 2. So the atom number should be 5 times 2 plus, now you see sulfur is 1 and 4 oxygen. So we have 4 and 1 5. So it should be 15. So it's not about the atomic number, it's about the elements or the atom numbers and different elements. How many elements? So if the question is how many elements are there in these compounds, the elements are 1, 2, 3 and 4. 4 elements like nitrogen, hydrogen, sulfur and oxygen. Here if the question is how many elements are there, now the question answer is 1, 2, 3 and 4, like nitrogen, hydrogen, phosphorus and oxygen. So 4 different elements joined together to form these compounds. But the question is what is the atoms number in these compounds? Then we need to think, okay, this is nitrogen 1 and hydrogen 4. So 4 and 1 is 5. 5 times 3 is actually 5 times 3 is 15 plus phosphorus 1 and oxygen 4 is 5. So 15 plus 5 is 20. So we can say that there are 20 atoms in these compounds and there are 4 elements in these compounds. This is ammonium phosphate and this is ammonium sulfate. And I hope you understand this is very easily understandable if you can remember one thing, the valencies of the different elements and radicals. If you can remember these valencies, then you can write the compounds. Now you try at your best level to write down all maximum level of compounds at your home, and this is your home practice. You do it and do let me know your feedback. That this is really understandable. Do you really understand that what I'm trying to explain since long time? So if I remove it, now you think you can use any of them, like okay, nitrate. So you know that this is nitrate. So if I use this one with this, any of them, like if you use hydrogen and nitrate, what would be? Say this is hydrogen and nitrate. As you know that both the things, hydrogen, the valence is 1 and this is also 1, so they will conjure together and form a new thing, which is hydrogen nitrate, or we can say this is nitric acid. Or even if hydrogen is joined with sulfate, now you see this is 1 and 2, so they will shift their positions and they put like H2SO4, and this is the hydrogen sulfate, or you can say this is sulfuric acid, and this is a widely, commonly and largely used chemical substance in the world. So this is sulfuric acid. Or even hydrogen mixed up with phosphate, then what will be? Like this is 3, oh sorry, this is 1 and this is 3, so it will be like H3PO4, and this is actually phosphoric acid. So I hope you understand. And if bicarbonate is added with anything, this is bicarbonate, this is bisulfate. Suppose this is H and this is HCO3. So as you know that this is hydrogen and this is bicarbonate. So both has one valences. So now if we add it, it would be H2CO3, and again we are producing one very fragile acid, which is called carbonic acid. Or even if you say that calcium is added with bicarbonate, then you think the valence of calcium is 2 and this is 1. So it would be like Ca, as 1 would be here and 2 would be there. We need to make a bracket and then HCO3 bracket close to. And this is the formula of calcium carbonate. If you don't put bracket, then what is the complexity will happen? That here it would be like HCO3, and now if you say this is 2, then that is a very big mistake. You see, it means there are 32 atoms of oxygen, which is extremely wrong. So we need to put another bracket there so that we can say that bicarbonate is 2 and calcium is 1. So I hope you understand that how to write calcium carbonate like this, calcium bicarbonate. But if it is calcium carbonate, like calcium and carbonate, you see both are 2, same, so it's done. So only we can say this is CaCO3, which is calcium carbonate. Now you can write number of compounds, only just changing their valences. And of course keep in mind the name, correct name of the elements and all the compounds. Like if hydroxide is used everywhere, if hydroxide, we take as an example of hydroxide, now you think that hydroxide is like calcium and hydroxide. Now you think that this is 2 and this is 1. So you should not write these as this. No, this is not, because this hydroxide is a radical. So you should put a bracket before writing this, and it should be like that. CaOH whole 2. That is calcium hydroxide. Or even if you say this is calcium and oxygen, then this is 2 and 2. So done. It will be like calcium oxide. This is lime. You know this is lime. And this is lime water. Calcium hydroxide or slaked lime. You know it better because already you started to, but I think this class is the foundation of your chemistry. If you know that the compound's name, how to write, this would be much easier for you to understand the next level chemistry. Right, whatever, you can have an idea from aluminium and hydroxyl. Now you know that aluminium is 3 and hydroxyl 1. So this would be like aluminium hydroxide 3. And if the question is how many atoms are there, then you can say this is oxygen and hydrogen together 2 times 3 is 6 and aluminium is 1. So the number of atoms in aluminum hydroxide is 7. If the question is here how many atoms are there, same. So 2, 1 and 2. So 2 times 2, which is 4, plus 1, which is 5. So 5 atoms are there in the compounds of calcium hydroxide. If the question is how many elements are there, then the answer is 3. Calcium, oxygen and hydrogen. And I hope you understand this longer version class. I'm just taking a long time because I hope I can control your retention power. And if you can see this whole video, please, after watching this, please take a sheet and try to write down a maximum number of compounds at your own hand so that you can see that what you have written, and try to name the compounds so that it will be better for you to understand the next chapters, and chemistry will be much more easier and interesting for you. Though chemistry is a really interesting subject, but I want that you understand and you can feel correctly that what is the beauty inside of chemistry. So after watching this video, still let me know that you understand really what I'm trying to explain, and please practice. So see you on the next class, and I'm coming with the fourth class. It is about the octet and duet rules, and then the ionic compounds formation, covalent compounds formation, and then the characteristics of ionic and covalent compounds. So I hope you will keep watching these videos and let me know your feedback. Take care, stay well, bye.